Welcome, learners. In this video, we will talk about another topic in the Solidity Advanced, which is basics of interface. In Solidity, an interface is a way to define contracts' external-facing functions without providing their implementation. It serves as a high-level description or a blueprint of the functions that other contracts can interact with. So interfaces are similar to abstract contracts, but don't specify any state variables to internal functions. The purpose of an interface is to establish a standard set of function signatures that other contracts can adhere to. By defining an interface, you can ensure that contracts implementing the interface provide the required functions with the correct function signature. Okay, here is an example of an interface in Solidity. Look at this block of code, interface, my interface. In this example, my interface is declared using interface. So we use interface keyword here. It defines two functions, which is getValue and setValue. The functions declared with the external visibility specifier. Okay, external here, visibility specifier, indicating that they can be called from outside the contract. And the view keyword is used for getValue function to indicate that it doesn't modify the contract's state. Other contracts can then implement this interface, by providing the necessary function definitions. Look at this block. In this code, my contract, which is a contract, okay, my contract is a contract, implements my interface. Implement my interface. This contract with the name my contract implement my interface, which is an interface here. It provides the implementation for the getValue and setValue functions according to their specific behavior. The override here, we use override. Override keyword is used to indicate that the functions are implementing in interface functions. Interfaces are typically used when you want to interact with external contracts or define a set of functions that multiple contracts should adhere to. So by utilizing interfaces, you can ensure interoperability and enable contract compositions that rely on predefined function signatures. It's important actually to note that interfaces cannot inherit from other contracts or interfaces. They only define function signature and don't contain any other contract level declarations. Look at now to this example here. Have an example, but at the first, in this example, we have a contract. My contract implements the interface. We have here interface example. So the name of interface is interface example. We put it in another file. So we have a file for interface and the file for contract. Implements all the interface functions. We should import the interface example. We should import our interface named interface example in this file in our code, my contract, okay, before deploying it. So let's go to this code line by line. Here we have an SBDX license identifier. It's a comment that indicates the license under which the code is distributed. So in this case, it specifies that the code is licensed under the MIT license. Okay, SPDX actually means software package data exchange, standard format for communicating software license information. Okay. About Pragma, this line sets the version Pragma for the Solidity compiler. It specifies that the code should be compiled using the version of Solidity greater than or equal to 0.6.12, but less than 0.9.0. Then here we have this code. Okay, let's go here. This code here, we have an interface example. This code declares an interface, this one, named interface example. An interface in Solidity defines a set of function, okay, declaration without providing the implementation, as we said in the slides. In this case, the interface declares three functions, as you see here: get str and set value and add. Get str, it's an external view function, okay, that takes that returns actually the string. It doesn't modify the contract state. Set value, external function that takes two unsigned integer parameters, num1 and num2, num1 and num2, okay, but doesn't specify return value. It can modify the contract state. About the add, it's an external view function that returns an unsigned integer. It doesn't modify the contract state. So interfaces are used to define a common set of function signatures that other contracts can adhere to. Contracts implementing this interface must provide the function definitions for these declared functions, so the interface ensures that contracts implementing it have the same function signatures, enabling interoperability between contracts. Now let's talk about the other file, which is contract. As we said about the SDX and the Pragma, we can ignore it now. This line is important. Import, interface example.sol file. This contains the interface declaration. So this file contains the interface declaration that the contract will be implemented. This is the file of our interface called interface example.sol. Here we import this file to implement it, okay? Now, so this is the first thing we should do when we use the interface. This code here, contract my contract, this code defines a contract named my contract, okay, which implements the interface example, okay. The contract here includes a private variable, as you see, num1 and num2, and it provides the implementation for the function declared in the interface. This is, we write here, we add the implementation of get str, set value and add, okay. And we use the override keyword actually, why? To indicate that the functions are implementing the interface functions, okay? So get str here, this function, returns the string hello world and doesn't modify the contract state. About set value, function here sets the values of the private variables num1 and num2. Add, the function add, returns the sum of num1 and num2. Okay, now we have here a contract call, which is this block defines a contract named call, creates an instance of my contract. So here we create an instance from my contract. Okay, we assign it to the OPJ. From object, okay, variable of the type interface example. This OPJ, the type of this object is interface example. The usage of the interface function implemented by my contract this one, okay? Get value function calls the function, this function, this function, this function calls the function from the object instance, demonstrating the usage of the interface function implemented by my contract. So in summary, this Solidity code demonstrates the implementation of an interface. My contract implements the function declared in interface example, and the call contract interact with the interface functions through an instance of my contract. So by implementing the interface, my contract ensures that it adheres to the expected function signature, enabling interoperability with other contracts that use the same interface. Let's apply this code. We should compile it at the first, then we go to deployment, but we should choose the contract here, call, then deploy. We can go to the get value. We should actually get the result, which is hello world. Yes, like this. I hope this video is clear. Thank you for watching.